Hello, my name is Jaylin Herskovitz, and I'm a fourth-year PhD candidate at the University of Michigan. And today I'll be presenting our paper titled Hacking, Switching, Combining: Understanding and Supporting DIY Assistive Technology Design by Blind People. This work was supported by my co-authors at the University of Michigan, Andi, Rahaf, Alharbi, and Anhong. Current AI-based assistive technologies can address simple and common use cases, but they tend to assume universal needs of blind and visually impaired people and are thus one-size-fits-all, rather than accounting for unique differences and desires. To illustrate this, I'll walk through an example given by P1, where they wanted to use the artificial intelligence application Seeing AI to sort mail. However, when they used their phone's camera to scan the envelope, instead of just reading out the information that was relevant to P1, which in this case was their name, the app frustrated P1 by reading all the text that it could see repetitively. In response, P1 imagined being able to filter text based on specific relevant properties, ignoring everything else and reducing their mental load. And this is just one example of how P1 engaged in the assistive technology design process. From cases like this, as well as from prior work, we know that blind people are domain experts in envisioning, designing, and hacking assistive technology. However, because of limitations in assistive technology design, individual needs often go unaddressed. In response to similar issues, do-it-yourself or DIY assistive technology movements have sought to address these unique needs. Additionally, BVI people already engage in customizing and designing their own high-tech assistive technology in order to better suit their needs as early adopters and domain experts in many capacities, like developing screen reader add-ons. However, there is still a range of high-tech assistive technologies that are difficult to hack and alter at the individual level due to both the skill and resources required and the impossibility of some alterations due to closed software ecosystems. But people still develop their own workarounds with these technologies. Thus, in this work, we aim to better understand current assistive technology tinkering behaviors so that they can be better supported by future DIY technology creation systems. Specifically, we aim to answer the following research questions. First, why do blind people customize existing assistive technologies? Second, how do blind people customize and hack assistive technologies currently? And finally, how would blind people envision creating assistive technologies in the future? We answered these three questions through a multi-part qualitative study. First, we conducted an interview with participants on their current use of existing assistive technologies, focusing on cases where they customized, created, or hacked assistive technologies to suit a unique need. Next, we conducted a 2-week diary study where we asked participants to record assistive technology use. With these first two parts, we aim to answer research questions 1 and 2, the why and how of current customization and hacking behaviors. Finally, we conducted a second interview asking participants to envision creating new assistive applications and technologies for their day-to-day tasks, and to provide their thoughts on the concept of DIY assistive technology in the future, our third research question. For this study, we recruited 12 blind adults who ranged in ages from 20 to 59 years old. These participants had a range of visual abilities in terms of light and color perception and became blind at varying ages. Now, jumping into our results. Through our analysis of the scenarios that participants discussed in each phase of our study, we highlight the long tail of unique needs and gaps in current assistive technologies that drive participants to desire additional customization. For example, the scenario given by P1 earlier. Next, we aim to understand how people currently customize and hack assistive technologies so that we can better support those behaviors in the future. We characterize how participants worked around gaps in assistive technology using 3 main strategies: hacking, switching, and combining. When hacking, participants often used assistive technology in a way that it was not originally intended in order to accomplish new tasks and thus discovered new ideas. With the switching strategy, participants switch between applications to account for deficiencies in assistive technology, either in different stages of a task or when one assistive technology stops working. Finally, with the combining strategy, participants use multiple assistive technologies at once as a way to blend features from multiple services. Each of these strategies has its pros and cons, and as P10 described, figuring out the right approach involves some trial and error. In their words, it's a lot of tinkering. We describe these instances as a form of design through use, and here I'll highlight one scenario where the hacking strategy was used by a participant. P4 described a situation where they wanted to organize books on their shelf. As a solution, P4 drew simple labels as a set of shapes on sticky notes. They then placed these on their bookshelf so that each label corresponded with a genre of books. Finally, they used Seeing AI to identify these labels when needed. This is a DIY approach to creating labels that can be accessed non-visually, created by P4 as they became blind. P4 eventually hoped to move from this hacking approach to DIY labels to tactile labels. However, the DIY labels served as an important workaround before they had access to tactile labels. By creating this workaround, P4 engaged in the assistive technology design process. Finally, we summarized participants' ideas and concerns about using DIY approaches, and here I'll highlight a few of those. As exemplified by the strategies for adapting existing assistive technologies, many participants were motivated in the past to create things that met their specific needs. P11 described one benefit of a DIY approach as the ability to personalize technology for themselves. They said, "I think that the value is that you can personalize as you wish, because sometimes you have an assistive technology, but it's not really personalized. I mean, this technology has to be made according to the preferences of many people." Participants often expressed constantly brainstorming or ideating on new assistive technology approaches. However, these ideas could go unrealized, and providing ways to scaffold and support DIY could bring those ideas to life. For example, P9 described one idea as having been on their mind for a long time. They said, "You never know, people might just be doing some trial and error and something great just might emerge. So you're giving people all of the ingredients and they can make whatever they want out of it." However, DIY creation, especially of high-tech assistive software, is not approachable due to both the technical skills required and the visual nature of assistive technologies. P7, a professional programmer, described difficulties envisioning new assistive technologies. They said, "I think that this is a little bit above my head. I'm not very good with AI, and I'm not really good, especially with images, so I'm not sure why those systems fail, and not knowing why they fail, I can't tell if they could work better in these situations." Finally, participants envisioned themselves taking on different roles in the creation process. Some envisioned the process as a collaboration between those with different skill sets. For example, P7 said, "I could see myself maybe as part of a focus group or a think tank." On the other hand, this could also be due to not having an opportunity to contribute to creation in the past. As P10 said, "I guess I haven't really thought of it, because it's just one of those things that you leave to the experts and hope that they get what you want." Given this variation, supporting users in whichever capacity they desire to contribute is key to expanding DIY creation tools in the future. Based on these findings, we summarize goals for supporting DIY creation in the future. These include improving the approachability of creating technically complex systems for non-programmers, supporting different roles and collaboration in the DIY process, and working to address the accessibility issues present when creating visual or camera-based technologies. Finally, from these goals, we consider end-user programming as a potential approach to DIY assistive technology in the future. End-user programming generally aims to make technical creation more approachable, for example, through block-based programming approaches, although these currently have some accessibility limitations. These approaches could also support a shared repository of tools to support collaboration between people with different levels of expertise. Additionally, in our paper, we describe how common use cases brought up by participants throughout our study map to existing end-user programming approaches like block-based programming. To summarize, in this work, we presented an understanding of how blind and visually impaired people currently engage in assistive technology customization and design, and how they envision DIYing assistive technology in the future. Thanks for listening, and I hope you check out our full paper.